In this video, we're going to go over the next 5 questions on the practice test. For this question, we want to consider the following system of equations. Negative 6x minus 1y equals negative 27, and negative 8x plus 6y equals negative 14. The question is true or false. The point 4, 3 is a solution to the system. For a point to be a solution of the system, we need that point, that ordered pair, to make each equation in the system true. So I'm going to find out whether this is a solution by substituting it into each equation and deciding whether we have a true statement or a false statement. The first equation is negative 6x minus y equals negative 27. I'll substitute 4 in for x and 3 in for y. That will give negative 6 times 4 minus 3 equals negative 27. Negative 6 times 4 is negative 24. Minus 3 does give me a negative 27 on the left-hand side. And so I have a true statement for the first equation. Now I'll check to see if it's also true for the second equation. Negative 8x plus 6y equals negative 14. Substituting the 4 and 3 will give negative 8 times 4 plus 6 times 3 equals negative 14. Negative 8 times 4 is negative 32. 6 times 3 is 18. And negative 32 plus 18 is a negative 14. So we have another true statement. So the ordered pair 4, 3 is a solution to the first equation, and it's a solution to the second equation. So it is true that it is a solution to the system. For this question, we want to solve the following system of equations with the substitution method. The system is x plus y equals negative 9 and y equals 2x. Now, with the method of substitution, your first step is to write one of the equations with the variable solved for, either x or y. And this system is given to us with y solved for in the second equation. So we already have that first step done. Then we can move to the substituting. We're going to substitute 2x in for y because we have it equaling y. So we substitute 2x into the other equation, and that will give x plus 2x equals negative 9. X plus 2x is 3x. And solving for x, we would divide by 3, and that gives x equals negative 3. So we now have a portion of our solution. We have the x coordinate. We need to find the y coordinate. And we can find the y coordinate by substituting this negative 3 in for x. And we can substitute it into either equation. I'll substitute it into the second equation, y equals 2x. So y will equal 2 times negative 3, and that's negative 6. So the ordered pair negative 3, negative 6 is a solution to the system. We can also check our work. We're going to check by substituting negative 3, negative 6 into each equation. For the first equation, we have x plus y equals negative 9. Negative 3 plus negative 6 equals negative 9. That's true. The second equation is y equals 2x. Negative 6 equals 2 times negative 3. Gives negative 6 equals negative 6, and that's also a true statement. So we have a solution to our system. On this example, we want to solve the system with the addition method. Sometimes this method is called the elimination method. We have the equations 10x minus 4y equals 40 and x plus 7y equals 41. Well, the first step in this addition or elimination method is to make sure that all of your like terms are lined up, and most importantly, your equal sign is lined up, because you're going to add your equations together, and you want to add like terms together, and you also want to make sure that your equation stays balanced. So in this problem, it was given to us with our x's lined up, our y's lined up, our constants lined up, and most importantly, that equal sign. Once we've done that, we want to decide whether we're going to eliminate the x or the y. And you can eliminate either variable, but sometimes one is easier than the other. So in this example, this x has a coefficient of 1, and that makes the process a little bit simpler. So we'll eliminate x. So once you decide on which variable you're going to eliminate, you want the coefficient on that variable to be the same number with the opposite signs. So since this is a 10, I want this coefficient to be a negative 10. And once we decide that, we can multiply by an appropriate constant to make that happen. So we're going to multiply by negative 10 to get that coefficient to be negative 10. The first equation is going to stay the same, 10x minus 4y equals 40. The second equation will multiply every term by that negative 10, and that will give us negative 10x minus 70y equals negative 410. Now we'll add our equations together, adding all those like terms. 10x minus 10x is 0x. Negative 4y minus 70y is negative 74y. 40 minus 410 is negative 370. So simplifying that 0x is 0, and 0 plus anything is just itself. So we have negative 74y equals negative 370. We're going to divide both sides by 74. Negative 74, and that's going to give us y equals 5. Once we get y equals 5, then we're going to substitute this back into either equation. So we can substitute for this y or this y. I'll use the second equation again. X plus 7 times 5 equals 41. X plus 35 equals 41. We'll subtract 35 on both sides, and we get x equals 6. So the solution to this system is 6, 5. We can check our work to make sure we didn't make any mistakes. In the first equation, if we substitute 6, 5, we would get 10 times 6 minus 4 times 5 equals 40. 60 minus 20 equals 40, and that's true. And let's check the other equation. We would have 6 plus 7 times 5 equals 41. 6 plus 35 equals 41 is also true. So this is the solution to our system of equations. For this example, we want to solve the system with substitution. And we have the system x equals negative 4y minus 2 and negative 3x minus 12y equals 6. Now with that substitution method, the first thing we do is to solve for one of the variables in either equation. We can solve for x in the first equation or y in the first equation, x in the second equation or y in the second equation. We can see that this first equation is already solved for x, so that's done for us. We're going to substitute that into the other equation. We're going to substitute in for x because this is equal to x. And that will give us negative 3 times negative 4y minus 2 minus 12y equals 6. I'll distribute that negative 3. We have 12y plus 6 minus 12y equals 6. 12y minus 12y is 0. We have 6 equals 6. Now you can see that as we tried to solve this system or solve for one of the variables, all the variables eliminated from the equation. And whenever that happens, that means that we have a special circumstance for that system. So when we have two straight lines, those two straight lines can intersect in a single point. So when we get an ordered pair as our answer, that is that intersection point. And then we also can have two lines that are parallel to each other. These have no intersection point, and there'll be no solution to that system. And then we have a third situation where the two lines are actually the same line, and they're right on top of each other. And in that case, there's infinite solutions. So these second two are the special cases. No solution and infinite solutions. And anytime all your variables cancel out when you're solving, you have this infinite solution case. You have one of the special cases. And then to decide which one you have, you've got to look at your final statement here and decide whether it's true or false. We have a true statement, and so because we have a true statement, it's going to be that infinite solutions case. So every ordered pair that is on the line is a solution to the system. Now the ordered pairs will take on the form x, comma, let's write it with negative 4y minus 2 comma y. And I wrote it that way because the equation x equals negative 4y minus 2 is that first equation. So I know the x coordinate will be negative 4y minus 2, and the y coordinate will be just y. So all of the ordered pairs will follow that pattern to be a solution to this system. For this question, we have a system of inequalities. Y is less than or equal to x plus 7. Y is greater than or equal to negative x minus 3. And we want to know which region or regions in the graph below represent the solution to that system of inequalities. So this question has already graphed the two equations, the two boundary lines. So what I mean by that is that y is less than or equal to x plus 7 is consistent of a boundary, y equals x plus 7, and then we have some shading. And the boundary line has been drawn. You can see this y equals x plus 7 has this line right here, a y-intercept of 7. This is slope-intercept form, that y-intercept of 7, and a slope of 1. You can see rise over 1. So this line right here is the line, that boundary line, y equals x plus 7. So we need to figure out the shading. Which regions represent the solution? That's the shading of these different regions. So to figure out the shading, I'm going to choose a test point. There's only one rule with the test point, that it cannot be on the line. Most people like to choose 0, 0 for the test point. You're going to substitute that into your inequality. We have 0 is less than or equal to 0 plus 7. 0 is less than or equal to 7. That's true. So here is my test point 0, 0. And it came out true, so that means that we're going to shade on the true side, which is below that line. But in order for the region to be a solution to the system, it has to be a solution to both inequalities. So now I need to do the other inequality as well. So the other inequality is y is greater than or equal to negative x minus 3. So we'll have a boundary line, y equals negative x minus 3. That boundary line has already been graphed for us. We have a slope of negative 1 and a y-intercept of negative 3. So you can see that y-intercept at negative 3 and our slope down 1 over 1. That's negative 1 slope. So we're going to choose our test point. I'll choose 0, 0 again, and we substitute that into the inequality. 0 is greater than or equal to negative 0 minus 3. 0 is greater than or equal to negative 3 is a true statement as well. So when we have our line, here's our line, and our test point came out true again. So we're going to shade above this line. I'm going to use a different color. We're going to shade above that line. And this region right here is shaded in both the yellow and the orange color. So these ordered pairs are going to be solutions of both inequalities. So we're going to select region A as the region that represents the solution to the inequalities. Thank you for checking out my videos. Have a great day.